Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mutakim Idrus, and today I would like to present my project which titled Effect of Structure Bite on the Aerodynamic. Okay, for the objective, the first objective that I would like to explain is about that I aim to examine the impact of external flow on the aerodynamic efficiency of the bicycle structure. And not only that, I also want to analyze how various design elements influence the drag and lift force acting on the bicycle during the motion. Okay, as an introduction, in the landscape of transportation, we could say that the bicycle stands as an emblem of sustainability, mobility with eco-friendly alternative. And not only that, this research project embarks on the comprehensive exploration into external flow, which effect on the aerodynamic of bicycle structure in terms of their design element, rider position, and also the external condition. By systematically investigating the external flow effect on the bicycle aerodynamic profile, we also want to refine the practical application in real-world design and manufacturing of the bicycle. And not only that, the exploration is powered by SimFlow, and the software is allows to simulate and analyze the aerodynamic behavior of bicycle under various conditions. And this study seeks to unravel the mysteries of this interaction, aiming to enhance the understanding of the aerodynamics toward bicycle structure performance. Okay, as we know, the simulation is running by using software SimFlow 4.0, and the STL format of geometry will be imported into the SimFlow before we start running the simulation. And then it will be scaled into the perfect unit, which is in millimeter. Okay, after the geometry loaded, the machine can be defined. The mesh need to be refined near to the structure bicycle geometry. And not only that, we move to the base mesh, which is a domain mesh. The mesh is created by carving out of the structure bicycle. And the base mesh boundary need to be assigned individual name to each side in order can be differentiate condition of each side. And next, the material point also can tell the machine on which side of the geometry that mesh should be retained. And as my project, the material point need to be located inside the base mesh but outside the structured byte. And then the mesh is ready to run out. Okay. Next, we want to move to another slide, which is I want to analyze the incompressible flow around the structure byte. We will use the simple form solver. And then the simulation will be used runs as turbulence modeling with model option of KW and ST. Okay, next, the project are simulating the structure bicycle cycling on a road. The road has to be moved respect with the bicycle. By that, we can say that we can achieve this by applying fixed velocity, which is 5 millimeter per second, into their boundary condition on the bottom of the domain. After set up all the boundary condition, the simulation can be processed. Okay, now we will move to the result part. The result obtained for the velocity of 5 millimeter per second, the velocity we obtain is with the speed millimeter per second, the velocity we obtain is 5 exponent 0, and the pressure is 9 exponent negative 0.5, negative 0.5. And as you guys can see there, the chart on the left side is the residual chart, while the right side is the um, force chart. The residual analysis serves as a crucial metric to assess the convergence of the solution. And not only that, the residual exhibit a gradual decrease over the simulation step, indicating a stable numerical solution. And the dynamic interplay between the bicycle structure and the sounding wind was then made clear by the force chart that was produced by the simulation. And what I can say, at a speed of 5 millimeter per second, the force and movement experienced by the bicycle are particular interest. Okay, as a discussion, let's we move into the discussion. The observed maximum velocity of 5 exponential 0 correspond to an optimal point where drag is minimized, showcasing the aerodynamic efficiency of the bicycle at this particular speed. Then, the pressure distribution with pressure of 9 exponent -0.5 complement the force analysis by highlighting areas of high and low pressure of the bicycle surface. As its implication, we can observe the maximum velocity and pressure at speed of 5 represent a good spot in terms of aerodynamic efficiency. The minimal drag at this speed suggests the bicycle structure at its current design configuration is adept at cutting through the air with reduced resistance, and the pressure distribution indicates a balance between the lift and drag, highlighting the potential for practical application in real-world cycling scenario. As overview, we can say that SimFlow simulation at 5 millimeter per second has offered a detailed perspective on the aerodynamic behavior of the bicycle structure, and the combination of the residual analysis, force and movement charts, and the implication of the velocity and pressure really lays the foundation for further optimization and real-world application. And as a conclusion, the SimFlow simulation has provided comprehension of the aerodynamic in controlling the bicycle frame in the presence of external flow condition. In order to further the overall objective of improving bicycle aerodynamic, the analysis can be improved in important new information about the performance measures, residual convergence, and also the interaction of force and movement. And this project overview discover that they may be used the importance of bicycle design, which will increase cycling accessibility and efficiency. So by that, I end my presentation. Thank you.